and I decided early this year to just dedicate an entire kind of philosophical discussion of what we're doing, why there is so much fuss about it, and the fuss in the form of an industrial move. So I'm going to go, this is the first talk ever I have given some numbers, and in particular due to the fact that humanoids possess 5 unique properties, and those include the kind of the classical robotics properties, speed, accuracy, repeatability, but now we have to add safety and intelligence as well, and perhaps there will be a 6th one even, there will be interaction and the kind of the flexibility of reprogramming every day. So with that perspective, there is an opportunity for humanoids to really augment our kind of labor operations, depending on what sort of technology adoption models we observe. And I'm going to go through literally business analysis of humanoid robotics today. Let me see if this functions. Looks like it doesn't. All right, just a reminder, this is my laboratory, Human Centered Robotics Laboratory. On the left side, we see one of my greatest prides, and we have here members of Apptronik. Apptronik came out of the lab with one of my students who has made the company very successful. He has nowadays more than 150 employees. He's going to grow to more than 200 pretty soon. And they have been very smart about customer relations and about the development of the technology and about embracing new trends of AI. On the center, and I'll talk about who's funding foundational research in humanoids in the US. There's not a whole lot of entities, but the US Space Force and NASA continue being some of the founding members of robotics. In this case, now for in-space operations, we're going to have humanoids doing extravehicular operations, in-space operations, which is a sort of a departure to what we have seen before. I'll talk about learning on the job. Many of us are doing that nowadays, but in humanoids, it's really making a very big impact. And then Seth mentioned that I'm the chair of Good Systems, the yearly position, and that means that I am now surrounding myself with people in the sociology areas, in public affairs, everyday citizens of all sorts, aside from the engineers and computer scientists and so on, to have some of the labor sort of efforts that are out there, government efforts and so on, in order to understand whether people really want to have robots around them, and what is the functionality. So kind of putting the problem before the solution, if you will. And then, continue operating some of these fantastic companies, where the Japanese have been often before the Americans and before the Chinese. They have really led humanoids around the world, and I'm deeply thankful to every single Japanese company. And I hope you guys continue developing humanoids and kind of go up the race around the world. Congratulations to Nancy. You beat all expectations on number of attendees, sponsors, papers, and everything. We had a pre-run of some of the competitions last year in Austin, where I was the general chair. Congratulations to Serena and Tabin. This is part of the competition that we envisioned and we executed, and it was a huge success. And I believe that today on the floor is even a bigger success. And all I hear is that we're going to see next year in Korea and the following years in the United States and so on, ambitious plans for competitions. We're redefining humanoids in big ways. Very happy to maintain the tradition of these kind of heavy parting students. That's part of the philosophy of humanoids. Don't let it go, okay? Luca, Dennis Hong if you're here, whoever. All right, and I want to go back back to some of the analysis I was doing back 17 years ago. The US National Intelligence Council produces reports about the predictions of technology around the world. That was 17 years ago. What would be today? And you can see that there's technology, which is the science of aging, the technology for aging. We have 3 on the energy domains. We have service robotics, and it's happening. It's happening. We'll see it now, right? And the Internet of Things is striking that no AI and ML. Right? In 2008, ImageNet was starting to be created. AlexNet was not there. That was 2012. ConfNets didn't make the impact up to the DNNs. We didn't have PyTorch. We didn't have transformers, any of that. So it was very hard to predict what's going to happen today. So the message I'm trying to give here is that whatever we have in our minds right now, it's going to be impossible to predict what's going to happen in 17 years from now. Just 17 years from now, right? What's going to be like 2041, something like that, right? So we're going to expect something that's going to blow our minds. I'm sure robotics will be at the center of that, and I'm sure humanoids will be at the center of that. I used to show this slide also many years ago, and now that I'm growing a little bit older than some of you here on the room, I'm really seeing relatives and friends even that they are becoming immobile at an early age, right? By age 70, 20%, and by age 18, 40% of the people are immobile. They cannot really move. That points out, and then the population dynamics tell us that in France, women live 86 years old, and men 80. Yes, sorry about that, men of France and the rest of the world, but that's the reality, right? So by 2100, we're going to have 1 billion people age 80 plus. So, okay, what thought it was on the slide, but exoskeletons, and I think we have here the wonderful Wondercraft, which I saw in Paris a couple of years ago. They have beat all expectations. There is one reason for it, because it is a technology that's going to be fundamentally needed. In some of our early works, we have with Apptronik. We dropped since then. That technology, we couldn't maintain the speed of innovation of France, hopefully, but fortunately, we did it with humanoids. That leads us also to this dichotomy between models and data-driven techniques. Not everything should be data-driven, not everything should be a model. If you predict the weather today, it is using fluid dynamic models. It's using some data, but it's still mostly classical fluid dynamic models. In the mass of dynamics, well, it turns out that there is this kind of hysteretic, pure imaginary terms. These are these, in principle, non-causal terms that you can actually turn them by some heuristics into causal terms, but they define the model behavior of the muscles very accurately, okay? So we're going to see this dichotomy all the time. We're going to see augmentation of humanoids and exoskeletons and other forms of walking systems with wearables, electronic tattoos, stress indicators, and brain signals. These are things that are happening, for instance, with my colleague Nanchu Lu in my lab. So all of these feature points that the killer app for humanoids is probably going to be assistive robotics. This is a picture that even Jae Hong and I, we participated with Honda many years ago on creating an image of what would be humanoids at home, and then showing up now in the age of robotics that we saw a few months ago with Tesla. We're seeing that happening, but there is a long way for humanoids to get home. Raising the funds and creating all of the services and all of the business model is going to be very hard. Really, what we are seeing, what we call the hard cash reality, is on this manufacturing, right? BMW, Hyundai, many of the Chinese car companies, Mercedes, some of the high-tech, OpenAI, and others that I cannot talk at this moment, are really the people are jumping right now and are fueling these hundreds of orders of humanoids that is going to grow pretty quickly. We're going to be at tens of thousands of humanoids very early. I'll talk more about that in a second. In the US, who's truly funding humanoids, there's only a couple of companies, a couple of organizations. One is the Office of Naval Research. And why is that? It's not only that it's difficult to move in this kind of Navy environment, with all kind of the rocking back and forth, with all these doors, with the knee knockers and so on, but it's what they call institutional learning. Those that like cognitive architectures, this goes back to this. It's the fact that these boats and vessels, they survive for tens of years, 40, 30, 40 years. Sailors are in the boats for about 5 years. Nobody remembers how to operate this diesel engine, this particular item, this box or whatever. So I see humanoids as this kind of recorders and sort of these legacies that they are taught verbally, emotionally, what's happening, how to take care of all this infrastructure, and they remember forever, generation after generation. I almost want to call it teaching from demonstration, which means that they acquire the knowledge and they can teach it back to future generations. That's why the Navy is interested in these technologies. NASA continues being a huge push for humanoids, and now the US Space Force, which is sort of this kind of new entity, they're putting a lot of money on building in-space operations. It turns out that I'm funded for that. Here on the left side, we see an image from many years ago, but iterations of that are happening. Extravehicular activity for repairing and servicing all of this economy of spacecraft, and which Texas seems to be the center. The next International Space Station is being built by Axiom, and the modules themselves are humanoid robots. They have multiple arms, they stabilize, they have cold propulsion and so on. So we're going to see embodiments of kind of things that are reminiscent of humanoids in space. Let's go back to some of the numbers. There are about 10, 11, and I know that these people differ in opinions, but I'm going to say that these 10, 11 European, American, Chinese companies are unicorns. They have reached valuations of over $1 billion. They all have something in common. They run for about 200, 300 employees. They are all in a Series B, maybe some of them pointing to a Series C funding, and they have orders of hundreds of humanoids out there. That's want to make the dynamics of humanoids go into the tens of thousands of robots. Now, who's the big winner of all of that? Amazon is manufacturing the people like Brad Porter and so on. They have proliferated all of these, Kiva and Spiral robots in the close to $1 billion robots. A billion robots. This is really what is succeeding today. We had a panel with Amazon. We asked them why this is happening, and if it was anticipated, and the answer was like, yes, of course it was anticipated. They're some of the smartest people in the corporate planet, but also things that we're seeing, a report from Morgan Stanley in which generative AI, all of the diffusion models, RL, and supervised learning, all of this is fueling humanoid robotics, and the fact that there is a TAM, a technology adoption model of 30 trillion, which is equivalent to 1/3 of the total world GDP, and a portion of that will turn into actual numbers. Let's see it here. There are 3.6 billion people employed around the world. That's a $30 trillion wage market. Sorry about that. 40K humanoids in 2030, 8 million humanoid robots by 2040, 60 million humanoid robots by 2050, according to the models from Morgan Stanley. That's with the TAM model, how many adoption of humanoids there are going to be by Morgan Stanley. About 1/10 of the total wages around the world are going to go into this domain. That's a $3 trillion market. And with prices about $50,000 per humanoid. I want to go there for a second. I think it's going to be much lower than that. A car, a Volkswagen, you might pay 25,000, 30,000 euros. The BOM, the bill of materials, is about $5,000. Half of it is the price of metal. It's $2 for aluminum, $2 per steel. So a ton and a half is about $3,000 in metal. It's half of the bill of materials. A robot has much less metal. So I'm expecting that the bill of materials of robots down the line is going to be something like $500 for sales of, you know, $2,000, $3,000 on the street. And only at that moment is where we're going to see these humanoids proliferating to, you know, hundreds of millions of dollars with the killer app of being at home in the assisted markets and others. I think I still have a few minutes. Let me slow down a little bit. Go to the next slide. All right, and for comparison, strikingly, if we go into the truck loading companies, you know, Covariant, Dexterity, Berkshire Grey, Muji, Boston Dynamics, and others, they have similar size of employees, maybe a little bit more. Maybe they are Series B, maybe gearing towards Series C. So they are not that far from the humanoid innovation companies. The big difference is that we're seeing exits. We're seeing exits to Intrinsic, which is Google, for a few hundreds of millions of dollars. We're seeing exits to SoftBank, also for a few $100 million. We're seeing exits to Hyundai for $1 billion, and so on. Is this good? Is robotics successful? I would say lukewarm. To me, a real good exit is an exit where the first 30 or 40 employees, they're able to buy a big house, a big mansion, take their first vacation in the big vacation in the last 20 years, right? If only the founders and the investors make money, that's kind of a hard win, okay? Humanoids, we're not seeing exits on humanoids. I'm really hoping that all of you guys are gonna make it happen. We're gonna have exits in humanoids that are gonna be hugely successful, okay? Part of the success is because we have speed, accuracy, repeatability, but now with humanoids we have intelligence, safety, interaction, reprogrammability in a daily basis, learning from demonstration, and so on. Distinguishing features. In here, in these rapid movements, we see this kind of basketball move, right? Like, you know, you can imagine like this very quick movement. It's exponential dynamics. Many of you know pendulum dynamics. I'm going to skip pretty quickly with some of these movies. They're fantastic. Stabilization. That's due to this inherent exponential dynamics. Teslas accelerate at a portion of a g, of gravity, so constant accelerations. That leads to quadratic displacement. So humanoids, you know, in the quick movements, they accelerate exponentially, where cars, they displace quadratically. So I'm expecting humanoids to do that, right? You cannot expect that to be done by a wheel robot. And it sounds like a joke, but that's what we see in Italy in a barista, right? They're making like 7 coffees at the same time, and that's what makes them valuable. So the impact that I see is in lean manufacturing, operating in this machinery, being able to change tasks rapidly, and being onboarding themselves in part of the culture of manufacturing and of the Kaizen, sort of minimize waste in these kind of small spaces. I don't think humanoids are going to be running from one side of the factory to another one. They're going to be living in these very complex, crowded spaces and doing things very quickly. Finally, I want to finish with intelligence in the job. This work with UK Zoo, wonderful to do collaborations with incredibly smart guys around. We go back to the combination of deep learning, RL, with supervised learning, and classical whole body control techniques. I will not go into the details, but both have a place and a go. There's our learning in SA3. We're actually using algorithms on non-Q on DBH spaces, which are invariant and better for learning from demonstrations. They're just wonderful technologies, and that changes the panorama of humanoids substantially, in that we can teach them in a way that we couldn't envision any time ever before. This is a gripper we're opening, where it's open source. We just open sourced it this week. You know, very cheap to fabricate. It uses robotics actuators. I don't get any commission, but I just like them. So congratulations, guys. And then you just wear it. It records the robot position. You push a button, opens, closes. The next version, you can even talk to it. And now we focus on cross-embodiment learning in the sense that you connect it to the gripper. You connect the gripper to the gripper of the robot, so you have to have kind of less of an alteration, and now it has learned the task outright for all of these machines. Here is the STL files and the BOM, where to buy them. Connections to this institutional learning is going to be very important. And then fueled by other technologies, optimization continues to be important, liquid cooling, explosive movement. After all, in order to make, do basketball, we need to have about 4 Gs of accelerations, 40 radian per second square. We might as well have explosive actuation. This is a concentric dual planetary gear. The outer ring is driven by an auxiliary gear that changes the gear ratio instantaneously. That's my last slide. Why all the robots wear tuxedos? I will never know. Thank you.
Thank you, Luis, for this useful insight on taking research to translation through various efforts and very interesting insights. So, can we've got time for a few questions, and can I ask the questioners to please come up to this mic here so that everybody can listen to the question. Good. Okay. So,
who plans to make a company in humanoid robotics? Raise your hand. 1, 2, 3. Francesco, you're cheating. Go ahead.
Okay. So let me start off with the question. So I think people have looked at things like doing learning in optimality and doing things in a sort of optimal way of achieving motion. How much do you think it is relevant in the real world in terms of this trade-off between safety, reliability, and optimality in the context of some of the applications you talked about?
Well, depending who's paying, I think that if any of you works with some of these parcel sorting companies that are coming, these covariants and Berkshire Grey, Dexterity, they work for track loading very fast. Every tenth of a second, every millisecond counts. In a sense, time optimal path parameterization became really a very important thing. Vibration reduction, for instance, third order constraints such that you move the box super fast, but you don't shake and smash things or lose the grip. So I do, from personal experience, I'm seeing that optimization in the industrial, kind of very aggressive timing applications is still key, right? At the same time, we all know the cons of optimization. The reward engineering is quite simple in general. There is no chance for RL. Robustness is low. The ability of incorporating new modalities of sensing is low. And then in that case, you just finding a solution, even it's already opening a lot of options. And you know a lot, maybe more than me about the second part. So appreciate the question.
Thank you.
So I can bring you the mic. You have a question, you don't need to come here to the front. So,
Luis, thank you a lot for the presentation and for the beautiful picture that we have seen there. My question is, in these new times, we have speaking a lot about generative AI, okay? And this forum, I know that we are more roboticists than AI, but how do you think that this new trend or these new tools can help in order to make better robots and better humans?
So diffusion models are truly magical, right? Is a potential way to do trajectory generation has been a pain point always. I think that, and then if I don't know if there's anybody here from ETH, but Tower, which was a search over trajectories of trajectories over precision and forces. You know, it gave you the spin, but the searches are tremendously expensive, right? So now we have an opportunity of searching over everything, points of contact, but also the profiles of the contact forces and the profiles of the trajectories themselves. And I do think that diffusion models and generative AI is going to make a big dent. That's my personal opinion. Now we have to see how it evolves. Right now we are very limited by providing information. You know, the search that we're performing are gigantic. We cannot afford making these kind of searches. We have to drive the search much more, and this is the only place where we can incorporate them as part of almost like a real-time loop, if you will. Thank you.
Thank you, Luis.